Okay, hello everyone, welcome. So, in this video, I am gonna give you a detailed walkthrough of my latest Selenium Java automation project. So, this automation project has been built around the obstacle list or obstacle course that is offered by Tricentis Tosca. So, for the unversed, Tricentis offers one automation obstacle course that helps us to gauge the test automation skills using their inbuilt tool, that is Tosca. Although I am not having the working knowledge of this tool, but I am having good working knowledge of using Selenium WebDriver. Hence, I decided to take part in this challenge, and here we are. So, the main intention behind creating this challenge is as follows, or creating this framework is as follows. First of all, I wanted to give you a taste of how powerful and how capable Selenium is. People tend to say that Selenium is outdated or Selenium is quite difficult to use, but that's not the case. It largely depends on the person who is using the tool, and it's less about the tool. Secondly, I wanted to share my knowledge, share my experience with the community. So if even if a one person can learn from this video or can get motivated from this video to start learning automation, so it would be great for me. And finally, I would say, like, it's a good mental exercise which uh, which enabled me to use my brain muscles, and I enjoyed a lot while working on this project. So yeah, that's about it. Right now we are having a total of 40 challenges on the website. These challenges come in varying complexities. So we might have a simple challenge in we just here we just need to click on a button and the challenge will be passed. And apart from this, we might have some challenge like bubble sort, in which we are required to automate the entire bubble sort functionality. Let me show you. Like, where was it? Yeah, here we need to perform the bubble sort functionality, or we can also literally play a game embedded in the web page, which I was not able to win at any time. So the agenda is as follows. First of all, I will be showing you the framework in action, all the 40 test cases running without parallel uh, execution, so that you can have a look at each and every test case individually and understand it better. After that, I will also run them parallelly, so that you can understand that we are able to run the test cases parallelly as well without any problem. And with that, I will start explaining you in detail about each and every file that has been used in the project, and also the idea or logic which I have implemented for automating a particular test case. So without further ado, let's start. Okay, let me check. Yeah, so right now this is our test suite in which all the test cases have been added, and right now we are not gonna execute them in a parallel fashion, so it will take some time. Just sit back and relax and see the execution happening. I'm coming in a minute. बात करो अपने पास ही अपने पास Okay, they are about to get complete. Yeah, we are on bubble sort now. Right, I think we are done. So all 40 test cases ran and there were 0 failures. And take a note of the time. It took around 4 minutes and 25 seconds when we ran them sequentially. So now let's try to run them in parallel. Let me, yeah, parallel equal to tests and thread count equal to 3. And let me now change the browser as well so that you can see that functionality also. And now take a note of the time. So it's gonna spawn 3 instances of the edge simultaneously, as we can see. So now the total time of execution will drop down drastically due to this reason. Let me show you. Yeah. right. This time it took 3 minutes and 5 seconds, and which is largely possible or due to the fact that this video is also being recorded. Else when I was running it locally, it was taking around 1 minute and 30 seconds. You can try it on your local system as well. So now I hope I have your attention. Now let's dig deeper into the framework and explain the purpose behind each and every file, and also the logic behind each and every test case. So you have already seen this general.properties file in action. So here we can add two properties, browser as well as the headless mode. For reading this general.properties file, we are making use of an open source library which goes by the name of owner, and the code related with that resides in the config folder. So we are having one interface named as the configuration that extends config, and here we need to add our keys which we need to read from our general.properties file. Then we also define a class which basically returns back a singleton object of our config cache of our configuration class. So by making use of this singleton object, we can inject these properties anywhere we need. After that, in every framework, there are certain constants which do not change throughout the framework. So for that, I tend to define a constants class. And a good practice is whenever you want to avoid the instantiation of a class, just make the constructor as private, and in that way no one will be able to instantiate your class from outside. But sometimes what happen is, even though the client or the caller code cannot instantiate your class, but this class itself can call the new, so it can write something as new constants. It can call the constructor internally, but in order to avoid that as well, you can throw new assertion error in the constructor, and then it will be also avoided to avoid the instantiation within the class itself. So here I have defined one create path method that will be responsible for creating the paths. And generally for the separation of concerns, I tend to define different static classes here, one as the common and one as maybe something like errors. Right now we are not having any as such error messages which we can store, but in case there were some error messages, so I would have stored them in a static class with the name of errors. So here I have added the base URL and the Selenium website URL, more on it in few minutes. Then the global wait out duration which we want to use, either we can use 10 seconds or 5 seconds. Then I have defined two directories, pages and test. I will explain the relevance behind them when we come on the utils folder. And downloads directory has been added because there are certain test cases in which we need to first download some data and then validate or perform some actions on that downloaded data. So we don't want the download to happen in our default directory. We want that downloads only happen within the context of our framework. So that's why I have defined the downloads directory to be located under the source test resources. So test resources, this will be the downloads directory, and here automatically all downloads will happen. Now coming to the driver instantiation. If you understand how to instantiate driver properly, then it won't be an overstatement to say that more than half of your problems will be resolved, because this is the most important part in the Selenium automation framework. So basically here I have defined 3 classes. Let me show. WebDriver Manager is responsible for spawning our different threads related to the drivers, because we also support parallel execution. So basically there are two methods, static methods, and once again, since we do not want the client to instantiate this class, so constructor has been defined as private. Get driver will be returning the thread local driver, and in case it's null, so it will be throwing an illegal argument exception. Set driver will be responsible for setting the thread local driver, and once again, if we pass the driver as null, so illegal argument exception will be thrown, or else our driver will be set in this thread local instance, and that will be returned using driver.get. And finally, we are having one quit driver method, which will be responsible for quitting the driver. After that, we are having a driver factory method, which is having one driver factory class, which is having one method by the name of init local web driver, and this accepts a string browser as the input. First of all, we just remove the trailing spaces and convert the browser name into uppercase. Now we try to pass this browser name into the browser factory, which is an enum defined. So this enum has been defined with the 3 different browsers that we support, that are Chrome, Firefox and Edge. And here also I have created 2 abstract methods and then overridden them in the enum instances only. And here only I am adding all the required options within the for the particular driver instance. So this is also important. In order to add the downloads directory, we follow this approach. We just add the preference in Firefox or add the arguments in our like create a map and then add the arguments in the Chrome options, and in this way we can set up our downloads directory. So this driver factory is gonna call this method, that is create driver of browser factory, these methods basically. In case we pass valid driver name, which is being passed from here, that is Chrome, Edge or Firefox, then the appropriate driver will be returned back from here. But if we try to pass an invalid name, something like I'm passing this, and if I try to run the test, automatically it will be skipped. Invalid browser name provided, this only following browser names are allowed: Chrome, Firefox and Edge. So that is being handled here. Let me show you. Yeah, that is being handled here only. So let me just fix it. Yeah, and now come to the listener part. So for the testing framework, I am using TestNG, and for the reporting, I am using Allure reporter. Whenever automation test is being performed, each test can have different statuses. A test might pass, it might fail, it might also get skipped due to some reason. So in order to listen to those events, we need to define a class which implements the iTest listener. So this iTest listener interface that is provided by TestNG, it's having these methods like on test start, on test success, on test failure and so on. And these are invoked based on the test status only. Like here you can see invoked each time a test succeeds, invoked each time a test fails and so on. And these are default so that we can just override them and use them according to our requirements. So what we are doing is, in both of the cases in which a test case is passing or either it's failing, in both cases I am gonna just save a screenshot as well. So for that Let me also show you the report once so that you have a better understanding. Yeah, so this is the Allure report, and as here you can see, for each of the test case a page screenshot is being captured like this for all 40 of these test cases. So it's happening because we have defined in our Allure test lifecycle listener that on test success we want to save the screenshot. And also if you see like on test skipped or on test where is it, yeah, each time I'm adding the attachment as test failure, test passed, which you can see here like this test is started, it's successful, and so on. And I have also added the links to each of the test case so that one can quickly open and navigate to the particular problem along with the required steps that are happening, like here it's calculating and entering the result, getting number 1, 2, getting symbol, and then finally entering the number. This was about the report. Now coming to Allure report helper. So here I am just adding the environment related information. So for this I am using a third party code which goes by the name of automated owl Allure environment writer, and just using its method, that is Allure environment writer, and passing the map of my environment information. Annotation transformer listener. So of course we try our best to write code in such a manner that our test cases are resilient and they do not fail. But of course unexpected things happen, and they happen more often than we think or anticipate. So in order to avoid that, we create two classes. One is the retry analyzer and one is the annotation transformer. So retry analyzer class implements the iRetry analyzer interface. In simpler terms, this is responsible for retrying the failed test cases. In our case, it's gonna retry each test case for maximum 3 times. If it's still not succeeded, then only it's gonna mark that test case as failed. Else it's gonna just keep retrying for 3 times, and in case it gets succeeded, then it will be marked as successful. In order to bind this retry analyzer with our framework, we make use of annotation transformer, where we set retry analyzer as the following class. We will talk about the pages after we have discussed support and utils, but in pages directory, basically I have added all the page objects, since we are implementing the page object model as the design pattern and best practices. So we separate out the uh, actions related to a particular problem in their respective pages, and in the test files we only write the code related with test. Okay, so now I would request you to just focus all your attention here, because what now I'm gonna show you is, I can say, most important files. These are the most important files in the framework. Selenium out of the box does not provide auto wait mechanisms. So whenever we write test, it's our responsibility to write test in such a way that all the waiting mechanisms are handled by us. For example, whenever a page is loading and you try to perform any action on the element, so you might get no such element exception, or you might get element not interactable exception, although the element might be there, but still. So in order to tackle that, we must be having resilient strategies at place so that we are able to write test cases properly. Although I have seen people writing code that they just include the waiting mechanisms directly into their files only. It also works, but I have found one way which I have implemented, and this is part of how can I tell, this is part of good practice which one should keep in mind. So let me tell you. First of all, we define one interface by the name of wait helper, and here I have defined the basically I am defining the contracts for all the kind of waits that I want my framework to have. So for example, wait for element to be visible. This method is defined and it's gonna wait for an element to be visible by this locator, and in case we are able to successfully wait for the time an element becomes visible, then it will return back the element. Like this you can read for each and every method that has been added here. Now since it's an interface, we also need an implementation class that's gonna provide us the code for these unimplemented methods. For that I have added a class which goes by the name of common page operations, which implements wait helper. Now if you might wonder what is this, like private final web driver, and why are we instantiating it in the constructor of this class. So for the unversed, this design principle or this design pattern is known as dependency injection. In order to define a wait, we need driver to be present. From where will this driver come? So we have defined the code, or we have written the code in such a way that whosoever wants to make use of the wait helper interface, they need to provide with the web driver, and that web driver, since we have added that web driver in the constructor, so it's not allowed to call or instantiate this class without providing a web driver first. And now if you see, for example, wait for element to be clickable. Yeah, so here what we are doing is, yeah, let me show you. So basically for each method I have written two overloaded versions. One is just gonna take the locator like this, and another one is also gonna take timeout in seconds. In case the client is providing the timeout in seconds, then these overloaded versions will be used, or else if no timeout is provided, so we are gonna make use of the global wait out time, global time wait out, which we have defined in our constants class, to be specific here. So how does it work is, if we just call wait element to be visible, so automatically it's gonna wait for 10 seconds, or else timeout exception will be thrown like this. Now let's talk about another most important class of the framework, that is page interaction helper. So this class is basically responsible for performing all the major operations on any web page. Here also, as you can see, I am injecting the web driver and wait helper dependencies into the particular class. Driver will be coming from the caller code, and wait helper will be instantiating using that driver only. As we saw in the common page operations, it's taking driver, and driver is coming from the caller code. I know it's a lot to digest, but just bear with me, stick till the end, and once I'm gonna show you the demo, I will also write some code to give you a proper demo. Then you are going to understand each and everything as crystal clear. So this class basically abstracts out all of the common operations that one can perform on page. like we can navigate to a URL, we can get the current URL, or we can click on the element like this. So internally, click on element will be using the wait for element to be clickable. Now it's gonna make sense to you. When code will call page interaction helper dot click on element, let me explain you in this way. Okay, where clicking is happening, let me see some simple test case where clicking is happening. Okay, let's uh, future halfway, yeah, this one, no, not this one, this one, yeah. So here we just need to click on a particular element, that is click B. Normally what you would do is you would write something like driver dot find element and here pass the locator, that is click B. Normally you would do this, but what if this element is not visible, or what if this is not clickable? So in order to solve these challenges, I have written this abstraction layer, that is the page interaction helper. So you are just responsible for calling click on element, that's it, and rest of the thing will be handled by page interaction helper only, which is gonna internally call wait for element to be visible or clickable depending on the method that is being called. I hope it's making sense. Okay, and all of the Java docs are also available to you, so you can just read each method, and I definitely believe you will understand what I'm trying to convey. Okay, what else I can show you here? So here we are having different kinds of methods. I think if when we will be on a certain test case, then you will be understanding these methods better. So yeah, this was about page interaction helper. Okay, and now coming to this class. So in uh, as far as this framework is concerned, for any challenge, what are we required to do? We are required to navigate to that challenge. Let me take some easier one. We are required to let me yeah, we are required to navigate to that challenge, and depending on the challenge we are required to perform some action, and finally verify that this good job is shown. In case this good job is shown, let me show you. In case this good job is shown and this you solve this automation problem, this p tag is shown, it means that we were able to successfully solve this problem. So this is some common behavior that is scattered across the application. So for that reason I have written these two classes, which one is a class abstract test helper and one is an interface that goes by the name of test helper. So just for the sake of completeness, I have written like I have done the same implementation in two different ways, so you can understand both of them. Okay, now coming to utils. So if you will carefully have a look, each and every page object as well as the test class, let me show, page object and test class, all of them are having a striking resemblance, or in simpler words you can say each and every file is based on a common template. So rather than me going and creating the files like this, something like new test and then uh, adding the dependencies that are required, writing this code and this code, so in order to avoid that, I have written this simple utility. What it's gonna do is it's gonna just go on this URL, which is this one, let me show, yeah, here, and it's gonna traverse each and every page and it will fetch the ID as well as the name like this. Let me, okay, let me show you in practically only, then you will understand. And what it's gonna do is it's gonna create these page classes as well as the test classes using the following code, that is create page class and create test class. Also for creating the or creating and cleaning the downloads directory, this code has been written. Okay, so if I show you, and already it has been mentioned that if the following class is there present there, so no new class has to be created. So right now no new class would be created, just you will be seeing all the names along with their IDs. Let's see. Okay, so as here you can see, class file already exists, test file already exists, and so on. And these are the related fields. For this not a table challenge, I want to create not a table page and not a table test, and this is the ID. Now if you may ask where ID is being used exactly, so ID is being used to navigate to this particular challenge like this, and it's also been used to add it in the Allure report as you saw earlier. Let me show you in one of the test, like this link, it's been used here as well. Okay, now let's close the extra classes. What else I can explain here? Support is done, utils is done. Yeah, string utils, so it has been just used in conjunction with the file creator utility only, in order to capitalize the particular text or create the test name based on the particular text. So for that I have created this class. These local main classes are for my local debugging purpose, which are not included in the GitHub code. So this was all about the main Java package. Under Java main Java resources, there resides two files. One is the general.properties, which we saw in the beginning itself, where we need to provide the properties, and one is the samplebook.xml. So it's just related with one of the test case, and it's just for the reference, nothing else. Now let's start with the Selenium base package of the test directory. So basically base test is responsible for spawning the WebDriver instances by making use of before method. And even before doing that, in the before suite, we are gonna just set up the Allure environment information using that uh, class which I showed you earlier, which was uh, not constants listener, yeah, using this class. So here what we are doing is, first of all, we are reading the configuration.browser, basically reading the browser name from general.properties. If it's null, then we are throwing an error, and in case if it's not null, then we are making a call to init local WebDriver, which internally is gonna call browser factory, which we discussed in the beginning itself. And once we are done with this, of course, as we saw, common page operations depends on the WebDriver driver. So here we are injecting the driver dependency in the base test. This ensures that each of the test case gets a fresh instance of the WebDriver driver, and there is no interference between two test cases. And here only we are also injecting the same driver in the page interaction helper. And in the teardown method, we are just calling the quit driver method of the WebDriver manager class. So this base test will be extended by our test classes, and in this way, whenever our test class execution starts, we will be having a fresh instance of the browser to be used in that particular test case. Like if you see addition test, it extends base test, and we have defined an addition page because all the actions related with this base test, oh sorry, this addition test are defined in the addition page itself. First of all, it calls the setup method, super setup method, basically calls this one, and after calling that, we are having the driver instance with us because we have defined it as protected, and page interaction helper is also protected, which we are injecting in the page instance. And then we are calling navigate to obstacle method. If here you will see pages navigate obstacle method. So here we have defined the particular obstacle id which we want to navigate to, and it's calling the base url which was defined here in the constants class. So now I hope everything is making sense to you and all the pieces are getting together. Now you can see how each and every element is interacting with the others. Okay, what else I can show you here? Now let me just give you a quick demonstration of like all of the concepts which we have discussed. So for this, what I have done is I have written a few sample test cases which just make use of the selenium.dev website only. For that, I have defined a separate base test class which goes by the name of base selenium test, and I'm here also doing the same work only. And here are the sample test cases. Right now there are two test cases: check if selenium heading is displayed and check if selenium documentation link is working. So if I run these, let me show you, two test cases will be ran. Yeah, so now to demonstrate how everything works in conjunction, what we generally do is, this is our page object class in which we have already added the dependency of page interaction helper. From where? From here, like this. From here we have already added the page interaction dependency, and now we are having the access to page interaction helper methods in our page class. So we can go ahead and write whatever steps that we need to perform here. What can we do for this? Selenium dot dev, let's see if we can, what can we do? Projects. Okay, so let's try to write a simple test case that projects link is working fine. So for this, what I'm gonna do is I'm gonna click on projects, and after that I'm gonna verify that projects is shown or not. Okay, so for this it's quite simple. We are gonna find the locator for our heading, which is this. Now let me show you one another important thing. Gone are those days when you need to enter private final by your hand. Just define a live template in IntelliJ IDEA and it's gonna do the work for you. Let me show. Private final by, like this. See how easier it is. Now projects heading. In case you are wondering how did I do this, so for that you just need to go to settings, go to live templates, and here you can add as many templates as you want based on your requirements. So right now I used this pfbx, so whenever I will be writing pfbx, automatically this code will be populated. And what does this dollar line dollar means? So basically cursor will be pointed here once I write this code. Like this you can define the templates. You can also go ahead and define the templates for file as well. Where was it? Like this. If you want to create a template for a particular file, and in this way only I have added, let me show, in this way only I have enabled that whatever class I write, something like demo, automatically my name as author will be populated. I don't have to do anything special with this. Okay, so we have written this. Now what can we do? Yeah, we also need to write the locator for link. Projects link. It can be found using link text, having projects as the link text. Now it's quite simple. Click on documentation link. Like this we can click on projects link, change its name, click on projects link, and check if documentation page is displayed. Like this we can check if projects page is displayed. Is projects link working? And here we first of all click on projects link. I have defined these methods as private because I don't want the client to have access to these, that's why. And now we want to check, so for that we return if projects heading is displayed true and our current URL contains projects. That was it. Simple, right? So now just go here, copy this and change the name. Check if projects link is working. Copy and paste these as well, change these as well, and just assert true that is projects link is working. And this is how everything works in a conjunction. It was passed, right? So I hope till now you have understood all of the things which I have explained, and I believe this video is gonna become quite long if I go ahead and explain the logic of each of my test cases. So I am thinking to just stop this video right now, and maybe in my next video I am gonna explain you the entire logic of each and every test case of mine, or else the entire code is already present at my GitHub repository. I'm not promising to make that video because it's gonna take a lot of time to just uh, explain the logic behind each and every of the test case. But I have written code in such a way that everything is quite self-explanatory, so you should not feel confused or lost because I have explained all of the important concepts of the framework in this video. So yeah, that was all about it. So first of all, thank you if you saw this video till here, and I genuinely believe that I genuinely hope that you are going with some new knowledge, new experience, and the time that you invested in this video gives you a positive ROI. And apart from this, just do not engage into passive learning. Make these kind of projects and practice as much as you can, then only you will gain the comfort to build more complex projects. That was all about it. If you found this video useful, if you found this informative, so please drop a like and do some good comment. Also comment if you are having any feedback, any suggestion for me, and also share it with your friends who might get benefited from it. Thank you once again, and I will meet you in some other video with such more informative and useful content. Till then, keep learning and practicing to become a good engineer.